to recap part one, I used the wave speed formula and the wavelength formula to finish part one. I got 54 meters over seconds. I'm on the maximum transverse velocity. Now, the only part we need from that was the angular frequency, which we found, and we plugged that into the maximum transverse acceleration formula. So now we're on part C, and it's what is the maximum acceleration at an antidote. Now, a good trick I learned in physics is converting acceleration to velocity to distance. That's the easiest way to think about it. To go from acceleration to velocity, you derive, and from velocity to distance, you derive again. If we're working backwards, which we are in this case, because the first thing we found was the velocity in part B, which is the v max is just is the amplitude times the angular frequency. Now we're trying to find the maximum acceleration. So all we're going to do is we're going to use that same Vmax formula. We're going to multiply amplitude by angular frequency squared. And it's going to look something like this. We just got to plug the same numbers from before. And 1357 times 0.17 squared. Now just plugging this into my calculator, I get approximately 2.58 and then a bunch of decimals or zeros. And then the unit is meters over second squared. And that is that first segment, those first part A, B, and C of homework 15.8.